All right, another question on assignment VV from somebody in the class was question number 19. And oh my goodness, I know why that's a question. Let's take a look. I believe this question possibly has a property that we may not have covered. Let's see. It says Molokini is a small crescent-shaped island. Extinct volcano. The approximate diameter of the mouth of the volcano. A geologist used a diagram like the one shown. They assumed the mouth of the volcano was a circle. All right. What is the approximate diameter of the volcano's mouth to the nearest 10 feet? What was the approximate diameter of the volcano? Oh, so we're basically saying is, all right, this is an island now, but it used to be a volcano. If it's a volcano, we're going to be able to see the entire circle. And I've been here, class. Actually, when you look under the water, you can see a ridge actually right around that crescent shape of the island to show you that there was a volcanic ridge before. So here's what I'm going to go with. First of all, we know we're dealing with a circle. So let's put a circle here. I'm going to move this a little bit, get it up here a little closer. Alright, so there is my circle. Let's go ahead and, I don't know, should we put a center there? No, let's not put a center. Let's draw the diagram here. So we have no idea where the center of this circle is, but we know there's a line right here. And we know there's a line right here. And they're telling us that these two lengths are congruent, and this is a perpendicular line. All right. So there is a property here that we need to know that probably is covered in section or module 19.4, but likely I'm not sure if it's covered in your notes or not. And that property is this. If you have a chord in a circle and you draw another chord that is perpendicular to that chord, not a chord, another line segment that's perpendicular to that chord, and it bisects that chord, then we know mathematically, class, that this chord right here, I'm going to try to draw it for you. Oops, that's the wrong drawing tool. Let's try to do a line segment. Then I know that this particular segment right here, if I can get that to be as straight as I can, must be a diameter. This is a diameter of the circle. So again, that rule would be a pretty obscure rule, and that rule is this. If you have a chord inside of a circle and you bisect it with another chord, then this chord absolutely must be going directly through the center. And that means if we can find the length of this chord right here from here to here, then we can find the diameter of the crater ridge. So now we just look at segment relationships of two chords. So I know this side was 225. I'm not going to write the unit of measure here. Let's just write down 225. That looks ugly. So 225.4. And this whole thing from here to here is 1180. Let's find half of that. So 1180 divided by 2 is going to give us 590, and that means this is 590 and this is 590. Well, class, we learned something. If I'm going to look for x here, we learned that we know that if these two are chords inside of a circle, then we know that this equation is true. 590 times 590, which are the two segments or two line segments of the first chord, must be equal to 225.4 times x. And if we can solve for x here, we can find the value of x, and then we'll add it to 225.4 to give us the diameter. So let's go ahead and crank this out. 590 squared, 348,100, so 348 1.48100 equals 225.4x. Divide both sides by 225.4. See if I can see this. So divided by 225.4, and that's 1544.4 if I round it. 1544.4 is approximately our value of x. So now I want to know my diameter. My diameter is going to be x plus 225.4. So I've got 1544.4 plus 225.4. And let's add that up together. 1544.4 plus 225.4. 1544.4 plus 225.4 equals 1769.8. So 1769.8, and our unit of measure here is feet. So there is the diameter of this crater, the original crater before part of this is now underwater. So hopefully that helps you see another property that you may not have known. Knew that this segment, this chord must go through the diameter. So if we find x, we can find the diameter of that circle.